Okay, so in this video I'm going to be solving number 7 and 8. Okay. Mute. Okay. So it says to explain your reasoning using the upper and lower bound test. Okay. So fx equals x to the fourth power. It's that. Okay. And then I actually don't really like to do this, but okay. So I'll get a random possible rational zero. So 1, 6, 6, as I said, y over x. So a possible rational zero. Actually, I don't know if anyone writes like that, but it's 6. So it is 6. Okay. It's just one of them. I don't want to do everything. Actually, let's do everything. It might help. I might just not use an online calculator to find the values. Okay, so x is 1. Okay, it's just 1. More specifically, plus minus 1, but I don't want to say that. And then 6, we have 1, 2, 3, and 6. Okay, so possible rational zero. I don't know if anyone writes like this, so it's probably a good idea to not follow it. It will be these. Okay, so let's see if for those who don't know the upper and lower bound test, if it's an upper bound, then for example, if 6 is an upper bound, I don't think it is, but actually I don't know. If 6 is an upper bound, then all the zeros are lower than 6, so it's smaller. And if minus 6 is a lower bound, then all zeros are larger than minus 6. So if it's also if minus 3 is also a lower bound, then that means that zeros are larger than minus 3, right? So in that case, therefore, yeah. So before we do anything, we have to know what makes an upper bound or lower bound, right? Like, after you actually solved it, if you don't know if it's a lower bound or upper bound, then what's the point? You just solve it for no reason, just because your teacher tells you to or the problem tells you to. And actually, if it didn't tell me to, I wouldn't use it, but I would just use an online calculator because that's way more easier. But if we want to do it, and if it tells us to do it, and if we don't want to use an online calculator, we can actually just solve it using the upper bound and lower bound and the possible rational zeros. Possible rational zeros. Okay, I'll just write it here so that I can use the new page. So let's start from 6. Okay, so what was our function? It was x to the 4th power plus x to the 3rd power minus 7x squared minus x, minus x plus 6. Okay, so let's put 6. 1, 6, 7, 42, 35. Okay, what's 6 times 35? 210, 219. 219 times 6 would be 1314, and that would be 1320. Okay, if we add them. So in here we can see that all of these numbers are positive numbers, right? Positive numbers, right? So this means that this number okay, because we didn't end with the 0 first, that means that 6 is not a 0. 6 is not a value of x that makes it's not a value that makes y 0, yeah? So we know it's not 6. So that's one thing we know. We learned from here. And we know that this is an upper bound because it's all positive numbers that we got from this synthetic, system, should I call it? So because this is an upper bound, we can know that the zeros that we have to get is larger. No, this is an upper bound, so the zeros are smaller than 6. Okay, if all are positive, that means that it is an upper bound. Okay, let's see an example of an lower bounds if we can. Okay, let's try to put 1. Or negative 6. I think that will give us a lower bound for sure. Okay, 1, -6, -5, 30, 23. Oh no. -138, -139, and then and then 834, and then we get 840. Okay, so what we see here is that it is plus, oh no, I don't like the color, it's too bright, plus, minus, plus, minus, plus. Okay, you see this? So this is a lower bound, meaning, actually maybe I should use this pen. This is a lower bound, and this means that the zeros are larger than negative 6. So this makes negative 6 a lower bound. Okay? So now we know that the zeros are smaller than 6 and larger than negative 6. Maybe we should write that. Yeah. So now we know that negative 6 is larger than 0 and smaller than 6. So now we know that we don't need that. So we have these. And actually, I was really tempted to put 1 and negative 1 because it's way more easier. And I just think and I just know that it's at least one of them. So now let's get the zeros, because now we can say that we know that the zeros are larger than negative 6 and smaller than 6. So I guess we can say that we use the upper and lower bound test. Maybe not. So 1 times 1, and that's 2. 2, negative 5, negative 5, negative 6, and then negative 6, that's 0. Okay? So what we got here, actually I'll just use this. What we got here is that, and this. Yes? So again, let's put negative 1. Negative 1, that's 1. Negative 1, that's negative 6. Then if we do this, we get 0. So this is that, and then this, right? And then a quadratic function is easy. X, and then 3, 2. There has to be one negative, and because this is positive, 2 has to be negative, okay? So we get this number, or no, not numbers, function, or so we get these, and now we know that x is 1, negative 1, 2, and negative 3. Yes. So, okay. For those who are actually solving this problem, and also for those who want to solve these problems, I will actually put in the descriptions. So we can say that by using the upper and lower bound test, we know that the zeros are larger than negative 6 and smaller than 6, and by using the synthetic system stuff, we now know that the zeros are them. Okay, this actually got way longer than I thought because I had to explain the upper and lower bound test. So I just wanted you to know the basic idea of it so that you can use it when you need to. Yeah, I'll just end it here and then solve problem 8 on the next video.